Black holes are one of the most devastating objects in space, sucking up everything around them. But there's another space phenomenon that's just as destructive. And it's known as a white hole. Now, what would happen if these two objects met in space and fought each other? Could something like this even happen? Who would win? And what is a white hole anyway? This is What If, and here's what would happen if a white hole fought a black hole. Before we get to our fight, let's see what these two opponents are all about. In one corner of space, we have the black hole. This legendary space occurrence is probably pretty familiar to you. Its signature move is to consume every piece of matter it comes in contact with. The white hole, you're probably less familiar with. And its signature move is to expel energy rather than sucking it in. So, with our two fighters having completely opposite attack strategies, who would win? Despite us not knowing much about our white hole mystery opponent, it's much more experienced at conquering space than the black hole is. That's right, the white hole is a proper journeyman and has been roaming space for millions of years, kicking butt and taking names. That's because scientists theorize that this white hole used to be a black hole. Scientists suspect that after millions of years, black holes will become white holes. And all the energy and matter they consumed over the years will be expelled back into space. That being said, when a black hole becomes a white hole, it might not last very long, so it will need to act quickly if it wants to pick a fight with a black hole. And despite it being different, the white hole is just as destructive as a black hole, if not more so. The matter the white hole is ejecting moves at the speed of light. So it's safe to say that the white hole is the veteran fighter in this situation as opposed to this up-and-coming black hole, but how much will its experience help it? After millions of years of causing destruction throughout the universe, our two opponents finally meet. They've battled asteroids, planets, and even stars, but they always managed to survive. Now they both face their greatest opponent yet. As these two massive forces approach each other, the black hole will instantly gain the advantage. The white hole will do its best to prevent the black hole from overtaking it, but unfortunately, it really doesn't stand a chance. That's because the white hole has no choice but to spit energy at its opponent. Although it was able to defend itself against everything else in the universe, unfortunately, the black hole is its one true match. The mass the white hole is expelling is also being turned into energy for the black hole. This won't be a quick battle either, as the black hole can feed on the white hole for thousands of years. And as it keeps feeding, the black hole is getting larger and larger. And now the black hole is ready for the finishing blow. It completely swallows the white hole. Now that it's consumed so much energy, our black hole is more massive than ever. It might be as big as the Messier 87, which is 38 billion kilometers across. For reference, that's 3 million times larger than Earth. So, if a white hole and a black hole collided, we'd have a massive black hole roaming around the universe, destroying everything in its path. And if it were anywhere near us, well, that would mean humanity would be in some pretty big trouble.
See that bright object in the sky? That's Andromeda, the closest major galaxy to our Milky Way and the most distant thing you can see with the naked eye. And it's racing towards us at the rate of 110 kilometers per second. Eventually, 4 billion years from now, Andromeda will merge with our Milky Way in a huge galactic collision. But what if these galaxies were to collide tomorrow? Would all the stars and planets suddenly plow into each other? Could our solar system survive this massive crash? And what would this galactic light show look like from Earth? This is What If, and here's what would happen if the Milky Way and the Andromeda galaxy collided. There are at least 100 billion galaxies in the observable universe, all colliding with each other. Larger galaxies merge about every 9 billion years, while smaller ones slam into each other even more often. Wait, what about dark energy? Isn't this hypothesized force pulling the universe and everything in it apart? It sure is. For nearby galaxies, though, gravity takes over. Andromeda and the Milky Way are no exception. They both contain central supermassive black holes that will eventually mesh the two star systems together. Imagine if that gigantic collision were to happen tomorrow. What would that look like? Andromeda's pretty far away. It couldn't just overcome a distance of 2.5 million light years in a single day. Let's assume that somehow the supermassive black hole in the center of the Milky Way increased its gravitational pull on Andromeda's black hole, and the big crunch happened 4 billion years earlier than expected. What's next? First, there would be no Milky Way and no Andromeda. The two spiral galaxies would become a totally different type of galaxy, an elliptical one. You can call the new galaxy Milkomeda or Milkdromeda, whichever one you prefer. Once Andromeda invaded Milky Way's personal space, the Sun and our entire solar system would be forced to the outskirts of the newly formed galaxy, 26,000 light years further away. And that's the best case scenario. In the worst case one, we might end up in a galactic Siberia, 160,000 light years away from Milkomeda's center. What about all the stars in both galaxies? Would they collide with each other? Some of them would. But even though Milky Way counts around 250 billion stars, and Andromeda has over 1 trillion of them, all these stars are separated by light years of empty space. It's unlikely that many of them would merge. Instead, they'd just get scattered into different orbits. Ooh, I forgot to mention, we invited a third galaxy to this party, the Triangulum Galaxy, or M33, a smaller satellite galaxy of Andromeda. This is shaping up to be a massive galactic mashup. For us Earthlings, this would look just incredible. The bright core of the new supergalaxy would set the night sky ablaze. Eventually, the two supermassive black holes at the center of these galaxies would come so close to each other that they themselves would merge. All the gas taken up by this monstrous black hole would form a bright quasar at the center of the galaxy. Another spectacular show for us here on Earth. Too bad in reality our planet won't live long enough to see any of it. By the time Andromeda slams into the Milky Way, the Sun would have already turned into a red giant and swallowed up the entire Earth.
Black holes are the gravitational monsters of the universe. They are so powerful that nothing, not even light, can escape their grasp. One black hole is bad enough, but if you took two black holes and smashed them into each other, they'd be capable of changing the shape of space itself. How epic would that explosion be? And could it somehow reach Earth? This is What If, and here's what would happen if two black holes collided. Of course, we have no means to capture or control black holes yet. So imagine you're observing one from a giant telescope here on Earth, and suddenly you notice something strange. Is that another black hole? It sure looks like it. And it also looks like these two are about to collide. It turns out that even gravitational giants like black holes occasionally run into each other in the seemingly vast universe. Are you about to see a nuclear bomb-like explosion of supersized proportions? The reality might be a little disappointing, but you still wouldn't want that galactic bomb to detonate anywhere near your planet. Bear with me here, because to understand how black holes collide, you need to arm yourself with a bit of theory. Black holes come in all shapes and sizes, and of course the magnitude of the collision would depend on which black holes are slammed together. Stellar mass black holes are the most common type. They can have up to 20 solar masses, but could fit in a ball much smaller in diameter than our Sun. Okay, now let's go back to you observing this gravitational show firsthand. First, you'd see the two black holes getting a little closer until they started to orbit each other. They would begin pulling matter and gas into a vortex between them. Get comfortable, because it could take billions of years for their centers to merge. But as the two black holes merged into one, they'd wobble a little and then settle down into a new, bigger black hole. Now, I hope you're not disappointed with such an explosion-free outcome. But wait, there's something I haven't mentioned yet. The excess energy from the collision would be expelled back into the universe as gravitational waves. As I mentioned before, colliding black holes can change the shape of the space around them. They do it by rippling this space with gravitational waves. Albert Einstein predicted gravitational waves over 100 years ago, but scientists didn't observe them until 2015, when the Advanced LIGO Gravitational Wave Observatory finally detected gravitational waves after 8 years of operation. The cool thing about these waves is that they affect the distance between the Sun and the Earth. They only change it by the diameter of a hydrogen atom. You'd need a whole lot of colliding black holes to really see a difference. But what about supermassive black holes? Would their collision be more explosive? These black holes have a mass of at least hundreds of thousands of times the mass of our Sun. But the thing is, they might never even collide at all. Two supermassive giants would get close to each other until they reached a gravitational balance and froze in their respective orbits. But add another supermassive black hole to the equation, and the three of them could tip over the gravitational scale and finally collide. Not in a massive cosmic explosion, but a silent merger, sending powerful gravitational waves throughout the universe. You know, despite the fact that black holes are an unstoppable, insatiable force from which nothing can escape, we have nothing to fear from their collision. Okay, maybe if that collision happened somewhere in the neighborhood of our solar system, then the merging black holes would rip all the planets in their vicinity to shreds, including Earth. The biggest planet in the solar system! And the smallest star in the known universe. Today, they're on a collision course, and Earth might not survive this. Meet the star with a catchy name, EBLM J0555-57AB. Its gravity is 300 times that of Earth's, and it's about the size of our Saturn. EBLM J0555-57AB is a red dwarf and the smallest star we've ever discovered. Usually, it resides 600 light-years away from us in its own double-star system. But not today. Today, it broke the cosmic speed limit and rushed toward our solar system to meet with the biggest gas giant in it, Jupiter. Let me just tell you, Jupiter is huge. It's about 11 times larger than Earth. It's even bigger than the red dwarf star coming its way, but because it's mostly made of hydrogen, it's not massive enough to be a star. To start converting all its hydrogen into helium and turn into a red dwarf, Jupiter would need to be at least 80 times more massive than it is today. So, what would happen if these two gas giants collided? Well, before the interstellar red dwarf could even make it to Jupiter, it would have to pass through the Oort cloud. The Oort cloud is a collection of icy comets and other bodies on the edge of our solar system. As the smallest star in the known universe was passing through this icy debris, It would wreak big havoc in our planetary neighborhood. Yeah, it would send icy comets our way, and some of them would start hitting Earth. We'd have to think of a way to protect our planet from this comet shower. But time would not be on our side, because the smallest star in the universe would keep moving toward Jupiter. Our stellar guest might be smaller in size than Jupiter, but it sure would be more massive. EBLM J0555-57AB's gravitational pull would start to tug on the planet. And don't forget that we'd now have a second star in our solar system. Things would start getting hot. All the heat from the red dwarf plus its strong gravity would make Jupiter grow in size. The gas giant's atmosphere would puff up as all the gases were heating up and expanding. Some of Jupiter's atmosphere would start to escape into space and toward the stellar intruder. Eventually, all the runaway Jupiter gases would form a hot ring around EBLM J0555-57AB. It would look as if we had a black hole in the solar system, only it would be really bright. The red dwarf star would keep slowly ripping Jupiter apart. Now it would be eating whole chunks of our gas giant. For a moment, Jupiter would take the shape of an American football, but soon enough, the star would engulf it entirely. Sorry, Jupiter, you didn't stand a chance. But now we'd be in a real pickle. Jupiter would no longer exist in the solar system, and now we'd have an alien red dwarf star surrounded by a ring of hot gases. Our solar system wouldn't be the same without Jupiter. This gas giant wasn't here for a cool view. Jupiter's gravity usually attracts asteroids and comets that make it into our planetary neighborhood. It gobbles them up before they make it further into the solar system. With no Jupiter to protect us from all the space rocks, Earth would be getting bombarded by all kinds of debris. Icy comets, asteroids, you name it. Every day we'd be hit by about 170 meteors, comets, and asteroids. That's 10 times more than what's making it to our planet right now. Life here would sure get more dangerous. Who knows how long before one really big asteroid would come and destroy all life on our planet. But things would get even worse. Having another star in our solar system would disrupt the orbits of all the planets it passed, including Earth's. Of course, it would take EBLM J0555-57AB millions of years to rampage all the way to our sun, so you might stay alive long enough to witness the epic slow-motion chaos. Unless the red dwarf sent another planet on a collision course with us. Yeah, that would end things much, much quicker. All the planetary collisions in the solar system would create a rippling effect. The planetary orbits would get disrupted even more as time passed. Earth could even get knocked out of its orbit entirely. This would send you and everything else on the planet on a rogue trip across the universe. And without the sun to give us warmth, the Earth would turn into a frigid, lifeless rock very soon. If you somehow survived up to this point, you wouldn't have very long now.
A black hole is on a collision course with our sun. And there's nothing left for you to do except sit back and watch the destruction of our entire solar system. How exactly would this epic collision unfold? How would this black hole end up in our planetary neighborhood? And what would it be like to witness all this from Earth? This is What If, and here's what would happen if the sun
collided with a black hole. A black hole is not much different than any other object that has mass, except it's dense, really dense. All the matter it possesses is compressed to an infinitely small point at its center, called a singularity. Most black holes are the remnants of massive stars. And just like the stars they used to be, black holes have a strong gravitational pull. The more matter compressed into its singularity, the stronger the gravity. There could be as many as 40 quintillion black holes in the observable universe. Many are located at the centers of their galaxies, like Sagittarius A star, the closest known black hole to us. It resides right in the center of the Milky Way. But black holes could also go rogue. After an extreme event like a collision between two galaxies, a black hole can break free and start to wander. There could be 12 of these rogue black holes in our galaxy alone, and one could be headed toward the Sun right now. If a wandering black hole were headed toward our solar system, it would first reach the Oort cloud. That's the sphere of icy objects surrounding the solar system, 2 light years away from us. As soon as a black hole came too close, the icy bodies in this region would be ejected from their orbits. You wouldn't be able to see the black hole for yourself until it reached the ice giants, Neptune and Uranus. Looking through a powerful telescope, you could see the gases being pulled away from these planets. All the gases and dust torn from Neptune and Uranus would form a region around the black hole known as an accretion disk. This superheated collection of gas and dust would orbit the black hole, making it visible. As it continued on its destructive path, you'd witness Jupiter and Saturn meet a similar fate. You'd be able to see with your own naked eye these gas giants disappearing from our night sky. Rocky inner planets like Mars, Venus, and Mercury would also be sucked into the black hole and destroyed into nothingness as you watched in horror. Only Earth would be spared. Not really, of course. I just wouldn't want you to miss out on your front row ticket to the destruction of the solar system. As the black hole approached our sun, you might think it would swallow it in one blazing gulp. No, instead, the strong gravitational pull would begin to pull matter from the sun, just like a strand being pulled from a ball of yarn. Huge portions of gas would be ripped away from it, and they would spin around the black hole, joining the accretion disk formed by the gas and dust of all our neighboring planets. This tearing apart of the sun would keep going until our star no longer existed. What's left behind would be nothing more than a gas cloud. Only the very end of the tail of this cloud might be able to escape the fate of being pulled into the black hole. As the sun's matter was being absorbed, lethal amounts of ultraviolet and X-ray radiation would be released in fiery explosions. This radiation would be hurled right in your direction, back on Earth. You wouldn't know the ultimate fate of the sun for 8 minutes. That's how long the light would take to reach us, but instead of the light source of our solar system disappearing entirely right away, the black hole itself could become extremely bright. Possibly trillions of times brighter than the sun. And with the sun swallowed up, the stability of what's left in our solar system would be completely destroyed. An entirely new gravitational balance would need to be established. And in addition to all the lethal radiation raining down on Earth, extreme tidal forces would push and pull at the planet. This would cause massive earthquakes, volcanic eruptions, and tsunamis. Eventually, Earth would crack into pieces. Or maybe, in the best case scenario, unceremoniously ejected from the solar system. Well, the reality is you and everything on our planet would be pulled right into the accretion disk along with all the other matter in our solar system. So now you'd have a new front row ticket to the inside of a black hole. A rogue star is headed straight for our sun. If these two stars slam into each other, it could spell the end of all life on our planet. How could a rogue star end up in our solar system? What would this epic collision look like? And how much time do you have to live? This is What If, and here's what would happen if a rogue star collided with the sun. As the name would suggest, rogue stars drift through space. They don't belong to any particular galaxy, or if they once did, they've been ejected from their homes at some point by supernovas or two galaxies ramming into each other. Whatever it is that sends these stars hurtling away from the gravitational pull of their original galaxies, it fires them off at very high speeds. In order to break free of our own Milky Way galaxy, a star would need to move as fast as 550 kilometers per second. Luckily, our sun is only moving at a mere 200 kilometers per second, not nearly fast enough to become rogue. But these wandering stars aren't all that uncommon. They may even account for as many as half of the 200 billion trillion stars in the universe. And one of them could be headed toward our sun right now. Meet Gliese 710. This rogue dwarf star is on a trajectory that would bring it close to our solar system in around 1.3 million years. When Gliese 710 eventually reaches us, it would enter the outermost section of our solar system, the Oort cloud, at a speed of about 51,500 kilometers per hour. It could send the icy bodies out there flying in different directions, maybe even right toward Earth. Once it has reached Neptune, the countdown to the epic collision would begin. T-minus 10 years till the impact with the sun. At this point, you'd better just plan to live your best life while preparing for the upcoming apocalypse. The gravitational pull of Gliese 710 would destabilize the orbits of our planetary neighbors, nudging them left and right. This could go as far as pushing Earth out of the habitable zone. Or it could turn us into a rogue planet after unceremoniously being catapulted out of the solar system. After 10 years, it would finally be getting close to collision time. As each day passes, things are only going to get worse. One possibility is that the Sun and Gliese 710 would merge into a red nova. This would result in a violent explosion that would unleash nearly 500,000 times more light than what the Sun does right now. Given the amount of time light takes to travel from the Sun to the Earth, you would be blissfully unaware of this destructive explosion for 8 minutes. But the moment you do find out, all that light would likely blind you in a millisecond and then immediately fry you on the spot. That's because directly behind this blinding light would be super hot gas. This wave of heat could be powerful enough to wipe out nearly everything in its path. Bye-bye Mercury, Venus, and yeah, Earth too. Our atmosphere and oceans would be completely blasted away. This would leave our planet as nothing more than a barren rock. The explosion would also have created massive amounts of high-energetic neutrinos. These would be able to boil you from the inside out. Earth would also be shrouded in lethal levels of UV and gamma radiation. Even if you somehow managed to survive the explosion, you wouldn't last long from the harmful effects of all this radiation. You'd have damage to your eyes, skin, and even DNA. Now, if an alien species was watching this all unfold from a distant galaxy with an incredibly powerful telescope, they'd see a single bright star surrounded by an excess of reddish-colored gas. And the infrared light left behind from the explosion would be visible for a long time after. But that wouldn't be the only way all this could possibly go down. There is a possibility there could be a more peaceful alternative. Yeah, if the two stars are moving a bit slower relative to each other, they could end up merging into one massive new star as they orbit each other. Our Sun would strip mass from its smaller companion, Gliese 710, and swallow it in a process known as stellar cannibalism. Then, this extremely hot and bright star would be called a blue straggler. Though it may sound many times more peaceful, this option would still likely spell out the end of life on Earth.
Whoa, watch your head! Some seriously big asteroids are crashing into Earth. What kind of shapes and sizes do they have? Which ones would have the deadliest impact? And which one would be most likely to hit us? Uh-oh, get your bunker ready. This is What If, and here's what would happen if the largest asteroid hit Earth. Okay, let's get the terminology out of the way. I say asteroids, but some of the objects on our list are not asteroids. They're comets. Both asteroids and comets are objects in our solar system, but they aren't the same. Asteroids are rocky leftovers from the early formation of our planetary neighborhood. And of the over 1 million that we know of, most orbit the Sun in the asteroid belt between Mars and Jupiter. On the other hand, comets are snowballs made of frozen gases, rock, and dust. They orbit the Sun, and when they get too close, they start to melt. This releases a giant cloud of dust and gas that can be larger than most planets. With 3,000 known comets in the solar system, could a few be ready to turn the Earth into a giant cloud of dust too?
Chelyabinsk meteorite.
Let's start with a smaller object that has already hit our planet. Meet the Chelyabinsk meteorite. It exploded over Russia in February of 2013. With a diameter of about 17 meters, it was relatively small, but the impact was huge. The explosion had the energetic equivalent of 500,000 tons of TNT. That's about 30 times as powerful as the bomb that was dropped on Hiroshima. It injured 1,200 people and caused enormous property damage. Pretty big effects from a little extraterrestrial visitor. Chicxulub. Moving on to something bigger, we'll go 65 million years into the past. The massive Chicxulub asteroid was likely one of the forces that resulted in the mass extinction of the dinosaurs. It was about 10 to 15 kilometers wide, and its impact crater in Mexico's Yucatan Peninsula measures 180 kilometers wide and 900 meters deep. Whoa! When this asteroid slammed into Earth, it devastated everything nearby. The blast wave sent enormous amounts of rocky material into the atmosphere, and it caused tsunamis as high as 1,500 meters. While all the soot didn't completely block out the sun, it reduced the amount of sunlight reaching the surface of our planet. That seriously devastated plant growth and had rippling consequences on the food chain. Eventually, it caused entire ecosystems to collapse. Oumuamua. Of all the objects that could collide with us, Oumuamua has one of the more interesting shapes. This rocky, cigar-shaped object is about 400 meters in length. NASA classifies it as a comet, but it exhibits traits of an asteroid too. And it doesn't have an attachment to any star system, so we don't know where in space it originates from. In 2017, it passed by the Earth at a distance of 41 million kilometers. Now, while we were safe from impact on that occasion, it could have resulted in a lot of destruction. If this interstellar guest crashed into Earth, darkness would cover our planet. And if the dust and debris stayed in our atmosphere for a long time, it would kill many plants, animals, and humans that depend on the sun. Bennu. Bennu is not only an asteroid you should worry about, it's the asteroid you should worry about. It has a 1 in 1,700 chance of colliding with Earth in September of the year 2182. At only half a kilometer wide, it's relatively small, but remember how significant the Chelyabinsk impact was? Yeah, with that in mind, you might be a little nervous when it makes a close approach to Earth every 6 years. Shoemaker-Levy 9. This next comet doesn't have any chance of hitting Earth. That's because it already collided with Jupiter in 1994. But you could imagine the destruction this 1.5 to 2 kilometer wide comet would have caused on our home turf. It broke into 20 pieces as a result of Jupiter's gravity. The collisions from these fragments were so powerful that they were similar to the detonations of about 300 million atomic bombs. Plumes of debris shot as high as 2,000 to 3,000 kilometers. And the atmosphere heated to scorching temperatures of 30,000 to 40,000 degrees. You must be pretty relieved that Shoemaker-Levy 9 never hit us. Ceres. Last, but far from the least, is an asteroid so big it's technically classified as a dwarf planet. Ceres is the largest object in the asteroid belt. It makes up 25% of the belt's total mass. The radius of Ceres is 476 kilometers. That makes it over 60 times larger than our ancient friend Chicxulub. If Ceres collided with Earth, there wouldn't just be devastation. There would be no Earth. The size of Ceres alone would block out the sun as it approached. And then, the impact would remove 10 kilometers of the Earth's crust. Hypersonic shockwaves would ripple across the globe. Everything in its path would be incinerated and leveled. Nothing would stand a chance of surviving. Our planet would essentially turn into a glowing ball of fire and melted rock. If by some miracle or secret underground bunker you survived, well, you wouldn't last long. Soot in the atmosphere would result in something like a nuclear winter.
A giant asteroid is heading our way. But no, it won't hit the Earth.
This asteroid is about to slam into the moon and crack it right in half. What would it be like to witness this epic collision? Would the moon break clean in two? Or would it shatter into a million pieces? And how could one of those pieces wipe out life here on Earth? This is What If, and here's what would happen if an asteroid cracked the moon in half. Before getting into our scenario, let me tell you about the time long ago when the moon almost exploded. It was a beautiful summer night in England in the year 1178. And 1 hour after sunset, people witnessed a spectacular phenomenon. A giant flame appeared around the upper part of that evening's crescent moon. And right before their eyes, the moon appeared to split in two before turning black. At least this is how the event was recorded by the local chronicler. As you could probably guess, the moon didn't actually split in half that night. It's possible that what these people saw was a large asteroid slamming into it. But an event like this would have sent massive amounts of lunar material toward Earth. More likely, what they witnessed was a meteorite entering the atmosphere and crossing their line of sight directly in front of the moon. This would have given the illusion of it splitting in two in a fiery fashion. But who needs illusions or questionable historical accounts when we could imagine what would really happen? Just get ready to avoid falling moon rocks. The moon is bombarded by hundreds of asteroids and meteorites every year. And without an atmosphere like we enjoy back on Earth, these objects don't burn up before impact. So even a meteorite as small as 25 centimeters across could have a big impact on the moon. In 2006, one approximately this size slammed into it. From Earth, the impact looked like a flash that lasted only 0.4 of a second. But it created a crater about 14 meters long and 3 meters deep. Taking things up a notch, a 40-centimeter meteoroid slammed into the moon at a speed of 90,100 kilometers per hour. This was such an intense collision that it caused a flash as bright as some of the stars in the night sky. That means when this happened in 2013, you could look up and see the events unfolding without a telescope. For one whole second, at least. The likeliest contender within our solar system of doing some serious damage to the moon would be Ceres. It's the largest object found in the belt between Jupiter and Mars. While it's technically classified as a dwarf planet, it's still only about a quarter as large as the moon. But even that wouldn't be enough to break the moon in two, or at least to knock it out of its orbit. For that, you'd need an asteroid almost the same size as the moon itself. And if this happened, you'd know it right away. About 1.3 seconds after impact, you'd see the moon being torn apart. Massive amounts of debris would be hurtling toward Earth. Some of this debris could be even larger than the asteroid that caused the mass extinction of the dinosaurs. But before you start picturing the life on Earth wiped out scenario, things might not be as bad as you think. Normally, Earth-bound asteroids travel at speeds faster than 100 kilometers per second. But it would be different for the chunks of the broken moon and the moon-destroying asteroid. These would have much lower speeds, and with that, much less energetic impacts. If you were lucky, the impact from even the most colossal pieces of lunar debris would release only 1% of the energy of a similar-sized asteroid. Adding to your luck, you'd get to witness a meteor shower of truly epic proportions as smaller bits of debris would burn up in the atmosphere. And this epic collision wouldn't result in two split halves of the moon now orbiting around Earth. Sadly, you'd have to kiss the moon goodbye. it would be shattered into a million pieces. But if it were to somehow break more or less in two, there would be a chance you wouldn't even know. At least not right away. That's because the asteroid could have split the moon right between the side that always faces Earth and its dark side. You could still see the front of the moon beaming down on you. Eventually, the two halves could escape each other's gravity, revealing two hemispheres in the night sky. And they'd stay like that for a long time, at least until the effects of gravity pulling each half from all sides shape them into similar spheres. But that would take millions, if not billions, of years. If the moon is blown to bits, our night sky would be permanently transformed into a dazzling sea of stars. Venus would become the new brightest object, despite the fact that it's 14,000 times less bright than the moon once was. Some of the more drastic consequences of the moon being destroyed would start to make your life difficult. The moon is responsible for the Earth's 23.4-degree tilt on its axis. Without it, this tilt could become as much as 45 degrees. That would make our planet spin nearly on its side, and this would mean the sun would no longer shine directly over the equator. Instead, it would beam down closer to the North and South poles. This would trigger some extreme weather and could lead to ice ages that occur on different parts of the planet as often as every few thousand years. And the tides would never be the same again. Earth's powerful tides are caused by the moon's gravitational pull on our oceans. The sun's gravitational pull on our sea levels is only about half of what the moon can pull off. No longer having the moon in our orbit would lower sea levels and have a huge effect on ecosystems in intertidal zones. Tidal wetlands species would now have even more fierce competition for food and shelter. This could really endanger a lot of marine life, like sea turtles. The rising and falling of tides is an extremely important factor in giving their offspring the best chance of survival.
In the center of our galaxy, the Milky Way, there is a supermassive black hole feeding on nearby stars. It's called Sagittarius A star. And if a giant gravitational monster slowly eating the galaxy isn't terrifying enough, there's another cosmic monstrosity lurking around it. Is it possible that one day they would get a little too close and collapse on each other? What would be left of the Milky Way if they did? Would there be even a slight chance that the Earth could get out of that safely? This is What If, and here's what would happen if a magnetar collided with a black hole. This monstrosity creeping through the Milky Way is a remnant of a giant exploded star. But it's not just any remnant. It's an extremely dense and very magnetic collapsed stellar core, a magnetar. Let me refresh your knowledge of magnetars. They're born when a star, at least 8 times more massive than our Sun, reaches its expiration date and explodes in a beautiful supernova. Much of that star is gone, but the dense core of it remains. Most of these remnants become neutron stars. They spin very fast, usually a few times per second, and they're composed of neutrons. Some neutron stars have such strong magnetic fields that they emit electromagnetic radiation from their poles. That makes them pulsars, and you can observe them with a telescope when their poles face the Earth. Only a few pulsars develop such an extremely powerful magnetic field. They become the strongest magnets in the universe, the magnetars. They spin once every 10 seconds, but their magnetic field is 100 times stronger than that of a neutron star. If one of those magnets came halfway between the moon and the Earth, well, It wouldn't be pretty. But would it be as bad from a distance of 26 light-years away? Well, what I'd like to know is, would a magnetar swallow a black hole, or would a black hole gobble up a magnetar? The collision of these two giants wouldn't end up in an explosion, but in a quiet cosmic merger, stretched over billions of years. Although magnetars are incredibly powerful, they would lose the battle with a black hole. Depending on the trajectory of the magnetar, as well as the size and mass of both the magnetar and the black hole, the magnetic monster would be eaten up either whole or slowly, piece by piece. As the magnetar was being torn apart by the black hole, it would be sending gravitational waves throughout the universe, disturbing the curvature of space-time. Once the black hole consumed the magnetar, its mass would increase and expand its event horizon. And thanks to this expansion, more and more stars would be flung into its dark density. The black hole would be slowly eating our galaxy, star by star. Eventually, after quadrillions of years of star consumption, the black hole could gobble up the Milky Way, all of it. By that time, humanity would most likely be long gone anyway. Nearly 800 million light-years away, something has been forming. Scientists aren't exactly sure what it is, but have dubbed it the Black Neutron Star. And now, it's headed for Earth. What is this strange object? How would it change our planet? And what makes this new discovery so dangerous? This is What If, and here's what would happen if a black neutron star entered our solar system. What is a black neutron star exactly? Well, scientists aren't entirely sure just yet, but they do have some theories. It all has to do with this mass gap that's found in space. When a star dies, two things can happen. If the star is more than 5 times the mass of the Sun, it becomes a black hole. And if it's under 2.5 times the mass of our Sun, it becomes a neutron star. But what exactly happens when a star is too small to become a black hole and too big to become a neutron star? That's where our new space object comes in. Scientists from the Laser Interferometer Gravitational Wave Observatory and the European Virgo detector have discovered an object 2.6 times the mass of our Sun. Scientists think there's a chance this object is either the heaviest neutron star ever or the smallest black hole. Regardless of what it might be, scientists also discovered that this mysterious space object merged with a black hole of 23 solar masses. This happened 800 million light-years away, but the gravitational waves it created were detected here on Earth. This could have created the most massive black hole to ever exist, but let's say this object, which is 2.6 times the mass of our Sun, didn't merge with a black hole. Instead, it came toward our solar system. What would happen then? Well, as the black neutron star came on the scene, gravitational disturbances would disrupt nearly every object within the solar system. All planets, comets, asteroids, and everything else in space would be thrown into chaos. There's a good chance that this would throw the Earth out of the habitable zone. Our planet could end up wandering in the far corners of space. And with the planet being so far from the Sun, Earth's temperature would drop significantly. Luckily, this wouldn't happen right away due to all the greenhouse gases in our atmosphere. But soon enough, Earth would become a frozen wasteland. And since we're not entirely sure what this object is, the results could be very different. If the black neutron star were a kind of magnetar, then we would experience intense solar flares as well. A magnetar can release as much energy as our sun has emitted in 100,000 years in less than 1 second. As Earth is completely frozen, it would then be quickly heated up as the black neutron star gets closer, vaporizing nearly everything on the planet. Not to mention, it would also cause tidal heating. The strong gravitational pull coming from this massive space object would deform Earth by heating our planet's core. This would also give rise to massive earthquakes and volcanic eruptions. And what if the black neutron star were just a really small black hole? Well, the results of it entering our solar system wouldn't be any less destructive. The black hole would slowly suck up everything in our solar system. It would grow larger and larger, making its way toward Earth. And once it gets to us, its enormous tidal force would pull Earth apart. And there's nothing we could do to stop it. There's also a chance that this black neutron star could be a regular neutron star that then becomes a black hole. This would result in Earth being quickly destroyed by all those consequences from before, and of course we'd all die. So yeah, sorry, we killed you a bunch in this one, but it just goes to show that we definitely wouldn't want these objects coming anywhere near us.
A rogue star is headed straight for our sun. If these two stars slam into each other, it could spell the end of all life on our planet. How could a rogue star end up in our solar system? What would this epic collision look like? And how much time do you have to live? This is What If, and here's what would happen if a rogue star collided with the sun. As the name would suggest, rogue stars drift through space. They don't belong to any particular galaxy, or if they once did, they've been ejected from their homes at some point by supernovas or two galaxies ramming into each other. Whatever it is that sends these stars hurtling away from the gravitational pull of their original galaxies, it fires them off at very high speeds. In order to break free of our own Milky Way galaxy, a star would need to move as fast as 550 kilometers per second. Luckily, our sun is only moving at a mere 200 kilometers per second, not nearly fast enough to become rogue. But these wandering stars aren't all that uncommon. They may even account for as many as half of the 200 billion trillion stars in the universe. And one of them could be headed toward our sun right now. Meet Gliese 710. This rogue dwarf star is on a trajectory that would bring it close to our solar system in around 1.3 million years. When Gliese 710 eventually reaches us, it would enter the outermost section of our solar system, the Oort cloud, at a speed of about 51,500 kilometers per hour. It could send the icy bodies out there flying in different directions, maybe even right toward Earth. Once it has reached Neptune, the countdown to the epic collision would begin. T-minus 10 years till the impact with the sun. At this point, you'd better just plan to live your best life while preparing for the upcoming apocalypse. The gravitational pull of Gliese 710 would destabilize the orbits of our planetary neighbors, nudging them left and right. This could go as far as pushing Earth out of the habitable zone. Or it could turn us into a rogue planet after unceremoniously being catapulted out of the solar system. After 10 years, it would finally be getting close to collision time. As each day passes, things are only going to get worse. One possibility is that the Sun and Gliese 710 would merge into a red nova. This would result in a violent explosion that would unleash nearly 500,000 times more light than what the Sun does right now. Given the amount of time light takes to travel from the Sun to the Earth, you would be blissfully unaware of this destructive explosion for 8 minutes. But the moment you do find out, all that light would likely blind you in a millisecond and then immediately fry you on the spot. That's because directly behind this blinding light would be super hot gas. This wave of heat could be powerful enough to wipe out nearly everything in its path. Bye-bye Mercury, Venus, and yeah, Earth too. Our atmosphere and oceans would be completely blasted away. This would leave our planet as nothing more than a barren rock. The explosion would also have created massive amounts of high-energetic neutrinos. These would be able to boil you from the inside out. Earth would also be shrouded in lethal levels of UV and gamma radiation. Even if you somehow managed to survive the explosion, you wouldn't last long from the harmful effects of all this radiation. You'd have damage to your eyes, skin, and even DNA. Now, if an alien species was watching this all unfold from a distant galaxy with an incredibly powerful telescope, they'd see a single bright star surrounded by an excess of reddish-colored gas. And the infrared light left behind from the explosion would be visible for a long time after. But that wouldn't be the only way all this could possibly go down. There is a possibility there could be a more peaceful alternative. Yeah, if the two stars are moving a bit slower relative to each other, they could end up merging into one massive new star as they orbit each other. Our Sun would strip mass from its smaller companion, Gliese 710, and swallow it in a process known as stellar cannibalism. Then, this extremely hot and bright star would be called a blue straggler. Though it may sound many times more peaceful, this option would still likely spell out the end of life on Earth. With our Sun now a massive blue star, the habitable zone of our solar system would be pushed further away. It's invisible, deadly, and sucking up every bit of matter in its path. The most massive black hole in the known universe is headed right toward Earth. What would you see as it started to slurp up the Milky Way galaxy? What kind of tasty dish would Earth become? And when it's finished with us, where would it go next? This is What If, and here's what would happen if the largest black hole entered our solar system. Black holes aren't that much different from any other object in the universe that has mass, except that they are really, really dense. At their center is a singularity, an infinitely small point where all its matter is compressed. The more matter that's condensed into this singularity, the stronger the gravitational pull. Most black holes are the remnants of massive stars and generally range between 10 to 100 solar masses. For the record, one solar mass is the equivalent of 333,000 Earths. That's a lot of gravity. But supermassive black holes, which lurk at the centers of many galaxies, could contain millions or billions of solar masses. And scientists think that there are black holes as large as 100 billion solar masses, aka stupendously large black holes or slabs. Catch one of these moving toward our solar system and get ready to wave bye-bye to all your conceptions of space and time. The largest known black hole, Ton 618, has begun its long trek directly toward our solar system, with its 66 billion solar masses in tow. And long trek is no overstatement. It would be traveling at least 10 billion light years to reach us. As it steamrolled through space, it would gobble every bit of dust and gas in its path. It would also snack on many stars before it even reaches the Milky Way. Depending on its route, this could mean hundreds of billions of stars added to its size. Before making first contact with our galaxy, it would have pulled in enough matter to disrupt its neatly organized spiral. You'd be able to detect its initial approach toward us as you observe the increasingly intense radiation it emits. Eventually, it would come bearing down on the last of the Milky Way's spiral arms, the Orion Arm. Ton 618 would gobble up its entire 20,000 light-year length. It would be like an unbelievably long buffet line straight to the center of our galaxy. Somewhere along this line, it would finally knock on our front door. The Oort cloud is a spherical shell of icy debris that surrounds the solar system. Or at least it was before Ton 618 showed up. It would then continue on its way and consume the Kuiper belt, just beyond the orbit of Neptune. The danger to Earth would steadily increase as hundreds of thousands of icy bodies would be sent hurtling this way. As Ton 618 kept pushing forward, it would devour the ice giants, Neptune and Uranus. And the gas giants, Saturn and Jupiter, would be pulled apart atom by atom. Not only the planets, but their moons and every asteroid that the giant black hole comes across. Any future plans by us to settle on Mars would be squashed, as the red planet would end up right smack in the middle of this black hole too. And now there would be nothing left in the way of Ton 618 and Earth. Now, while the center of this stupendously large black hole would be almost 295 billion kilometers away, we'd finally be right up against its event horizon. That's the boundary marking a black hole's point of no return. The pull of its gravity would now be totally inescapable. Our whole planet would stretch out while simultaneously getting more and more compressed. Eventually, Earth would become like a strand of spaghetti, slurped into an empty black void. Then, this black hole monstrosity would gobble up the sun in one big gulp. And now, at the center of what was once our solar system, Ton 618 would occupy nearly as much space. It would extend almost all the way to the inner edges of what used to be the Oort cloud. And since it's not polite to leave any food on your plate, Ton 618 would continue on its path toward the black hole at the center of the Milky Way, Sagittarius A star. As these two massive black holes collide, the collision would be so powerful that it could cause ripples in the very fabric of space-time.
Imagine you're out for a walk on a lovely day with not a care in the world. The birds are singing and the sun is shining. Actually, the sun seems brighter than usual. And come to think of it, your skin feels kind of funny. It turns out that's not the sun at all, but the radiation and gamma ray filled light coming from
a quasar. So, in short, you're in serious trouble. How did a quasar even get here? And what would happen to Earth if a quasar moved into our neighborhood? This is What If, and here's what would happen if a quasar entered our solar system. I hope you didn't have any plans today, because the brightest object in the sky has set up shop in our solar system. So what exactly is going on anyway? A quasar is the result of two black holes colliding to form a supermassive black hole, with a central mass that outweighs our Sun by 1 billion times. When black holes merge, everything goes out of whack. The two black holes begin to consume all the gas and dust from each other, along with anything else in the area. Okay, so if they're eating each other, why are we seeing that bright light? Well, the material that's thrown off begins to glow from pressure and friction, resulting in the blinding light you're seeing. If this were to happen in Earth's vicinity, it would be a result of the black hole in the middle of the Milky Way galaxy smashing into the black hole at the middle of the Andromeda galaxy, which is 2.5 million light years away. If these two met, we'd be looking at a massive amount of infrared light being expelled into the universe. Oh, and it's also a harbinger of death and destruction, too. What would happen to our planet? Well, brace yourself, because this is going to be a doozy. Quasars throw off jets of particles that are so bright they outshine all the stars in their galaxies. So our sun would essentially turn into a candle in the middle of a very bright spotlight. The illumination from a quasar, along with all the radiation it throws off, would mess with Earth's atmosphere. The light is enough to energize particles that make up the atmosphere and free them from Earth's gravity. Our atmosphere would be destroyed, and we really need our atmosphere. It's our protective layer that keeps things in order and regulates the temperature. Without it, the oceans would dry up, Arctic ice would turn into water vapor, and everything would get much hotter. In addition to it being blindingly bright, we would have no safe air to breathe, no plants to eat or feed animals, and there would be no water to drink. Life on Earth would be a write-off. This would all happen very quickly, so you wouldn't have to live through a long, drawn-out apocalypse. At least you can look forward to that. But could this sort of doomsday scenario actually occur? Well, yes, but not for another 3 or 4 billion years. At that point, the sun will be flickering out. And by that time, we're pretty sure something else we've covered on What If would have taken us out first, so we won't even be around to see it. A dark, mysterious object has appeared at the outer edges of our solar system. It looks like the remnants of a dying star, but it behaves like a black hole. Your mission? Traveling right into its heart of darkness. What makes this mysterious object unique? How dangerous would it be to experience such powerful gravity? And how might this turn into one of the strangest experiences in the universe? This is What If, and here's what would happen if you fell into a black neutron star. I know we've talked about black holes before, but let me do a quick recap. A black hole isn't much different from any other object with mass, except that it's really dense. All the matter it contains is compressed into one point called a singularity, which is so small and so dense that our understanding of time and space within it breaks down. That singularity is what causes black holes to have enormous gravity. And then there are neutron stars. These form when a large star collapses at the end of its stellar life. A star that was once 1.5 times more massive than our own sun would now only be about 20 kilometers wide. That's no bigger than a city. But what you have lurking on the outskirts of the solar system is something else entirely. Too massive to be a neutron star, too small to be a black hole. This is a black neutron star. Not much is known about these objects, and what we do know, you're about to learn the hard way. For this scenario, let's ignore the fact that it would take you thousands of years to travel all the way to the outskirts of the solar system. Let's imagine that the best scientists on the planet came up with a way to roam our planetary neighborhood really fast. And now you'd be observing this gravitational monster up close. You'd know exactly where a black neutron star was making its catastrophic approach because of all the radiation it emits. This is the same way you'd find either a black hole or a neutron star. And just getting close enough to observe this star won't be enough. You need to venture right into its center. Your mission would require some protective gear, and this gear would need to keep you safe from some of the most intense forces of gravity in the universe. So don't take this preparation lightly. The black neutron star would be pulling you toward it with gravity about 2 billion times stronger than what you're used to on Earth. The problem is that the kind of intense gravity protection gear you need doesn't exist. Without it, your mission would be of the suicidal variety. As you got closer, different parts of your body would experience different gravity. If you were diving into this monstrosity head first, your upper body would get stretched a lot more than your legs. As you got closer to its center, you'd be spaghettified. Yeah, you'd become long and thin from your head down to your toes, just like spaghetti. Only this would be one brutally painful plate of pasta. But since you'd be on an incredibly important mission, you'd have the best equipment you could ever imagine. The best NASA scientists would supply you with a suit resistant to the extreme pressures, temperatures, and radioactive matter inside the black neutron star. Now would be the time for the task at hand. You'd dive layer by layer into an object of incredible mass. It would be like falling into our sun if it was squeezed into the size of a small city. On the outside, the black neutron star would look like any other kind of star, except that it would be really toasty. Your regular neutron stars are extremely hot, usually about 1 million degrees Celsius. A black neutron star? Well, you'd have to find out its temperature on your own. I bet it would be just as scorching. First, you'd pass through a gaseous layer of hydrogen and helium. After that, you'd find yourself on more solid ground. Scientists think that the second layer would likely be composed of iron and silicon. To continue your mission, you'd need to somehow punch through this blazing solid surface. Well, lucky for you, NASA equipped you with a super powerful drill that can withstand the heat. And things would start getting dangerously dense. Hope those guys at NASA made you an extremely durable suit, too. Down at the heart of the black neutron star, you'd notice a unique material, one of the strangest in the universe. Scientists call it nuclear pasta. Inside the neutron star, the nuclear clusters get packed so densely that they create the hardest matter ever known. At least this time it's not you that's turned into spaghetti. If all this talk about you being turned into some sort of food item has you worried, well, brace yourself. The madness would just be getting started. Now, you'd be so deep that the intense levels of pressure around you would be about 3 times higher than the density of an atomic nucleus. Protons and electrons would combine into neutrons. Hey, well, now you know how neutron stars got their name. As these newly formed neutrons start to overlap more and more, you'd keep traveling further and further down. Eventually, you'd find yourself face to face with the squished components of neutrons and protons, quarks. Finally, approaching the core of the black neutron star, you'd be nearing maximum bizarreness. Of all the squishy quarks surrounding you, there would be some so weird that scientists call them strange quarks. These quarks are heavier than other quarks, and they've earned their name by possessing a property known as strangeness. All it means is that strange quarks have less chance of being torn apart by the black neutron star's electromagnetism. Inside this core, the strange quarks would form a soupy mixture known simply as strange matter. And encountering strange matter would be the very end of the journey for you. Strange matter is contagious. That means when it comes into contact with ordinary matter, like you, it would generate more strange matter. So as soon as you'd touch it, it would instantly dissolve your protective gear and immediately after that, your whole body.
This is the most powerful object in the universe. The biggest spinning magnet to ever exist. It's the cosmic equivalent of a great white shark. But it wouldn't eat you. It would just turn all your atoms to dust. This is What If, and here's what would happen if a magnetar entered our solar system. If you thought neutron stars were big and scary, well, you haven't heard of their more powerful stellar cousins yet. Like neutron stars, magnetars are leftovers from supernova explosions. They're just packed with a lot more matter. Their density is so high that a single teaspoon of a magnetar could weigh in at 1 billion tons. They're also the most magnetic stars we know about. We use a unit called a Gauss to measure the strength of a magnetic field. Earth's magnetic field is only about 0.6 Gauss. The magnetic field of a magnetar can be as strong as 1 quadrillion Gauss. How long would it take a stellar monster like that to rip our planet apart? It wouldn't be the worst thing in the world if a magnetar was sitting quietly in our galactic neighborhood. But if it decided to stop minding its own business, there are 2 ways a magnetar could end all life on Earth, together with the planet itself. It could get too close to the planet. You'd start to feel its presence when it was about halfway between the Moon and the Earth. At that distance, a magnetar would erase the information off all your credit card's magnetic strips. Whatever you do, try not to get closer than 1,000 kilometers from a cosmic invader. Because if you did, your atoms would get stretched out of shape. Your bioelectric field would get scrambled, disintegrating your molecular structure. And your body would just disappear. Alternatively, a magnetar could destroy us from much, much further away. As if being the biggest spinning magnets in the universe isn't enough, magnetars can also be affected by something called starquakes. Starquakes happen when a star's crust cracks, letting massive amounts of radiation out into space. This blast of radiation could compress the Earth's magnetic field and partially ionize the Earth's atmosphere, even from 50,000 light years away. We know this because we've already come a little too close on at least one occasion. In 2004, gamma radiation from a magnetar reached our planet from outside our Milky Way galaxy. In just 1/5 of a second, it released more energy than our Sun has released over the last 250,000 years. Move that magnetar and its starquake up to 10,000 light years away, and things would get much worse. First, it would destroy our ozone layer. Then, it would wipe clean most of the planet's surface, along with all life as we know it. The truly scary part of this is that we wouldn't even know the magnetar was heading towards us. It would be a blink and you're gone scenario. I won't lie to you, there are magnetars close enough that if one had a violent starquake right now, we'd all get wiped out very fast. When scientists began their search for these interstellar monsters 40 years ago, they didn't realize how many of them exist out there. You might find some comfort in the fact that most magnetars don't make it much past their 10,000th birthday. Their short lifespan ends with them becoming neutron stars. Still dense and still magnetic, but not nearly as dangerous as a magnetar.
What would happen if you flew into a wormhole? Would you ever hear back? Where would you end up? Back in time? Another galaxy? This is What If, and here's what would happen if a wormhole formed in our solar system. You've probably heard of wormholes through Thor, Interstellar, Star Trek, or if you're really old school, Albert Einstein. In 1935, Albert Einstein and physicist Nathan Rosen came up with the idea of bridges in space-time. WTF? OMG. Sounds like you're catching on, because an Einstein-Rosen bridge, or a wormhole, is also a shortcut through space-time. A wormhole is less like a bridge and more like a tunnel. It's a tunnel that links two different points in space-time. And if you were to pass through it, you could end up in a different galaxy, a different universe, or 14th century Europe. Ugh. But only if you found a way to keep the wormhole from collapsing on you. The trouble is, no one's ever seen a wormhole before, and we probably won't find one anytime soon. The other problem is, if wormholes do exist in our solar system, they're probably microscopic. Any wormhole that could accommodate human travel would require a crazy amount of mass. Think about it. The smallest black hole is thought to be the size of an atom, but with the mass of a mountain. So, while we can't really calculate the mass of a wormhole that could fit a few of us in a spaceship, just know that it would be astronomical. And its gravitational pull would probably redirect the tilt and rotation of all the planets in our solar system. But things would go back to normal soon enough. Wormholes are incredibly unstable and are prone to collapse quickly. This is because the walls of a wormhole attract each other, which is why the wormhole would probably close shortly after it opened. Unless you had some exotic matter. Don't get too excited. Exotic matter is negative energy, and it's what you'd need in order to repel the gravitational forces trying to bring the walls of the wormhole together.
You shall not pass!
Unfortunately, it's unlikely that such matter even exists in our universe. But if you're already set on making a trip across the universe, there's just one more thing you should know. The laws of physics say that you wouldn't be able to put enough negative energy into a wormhole to keep it from collapsing. But on the bright side, that rule hasn't been tested yet. So, giddy up, space cowboy. Ride on, prove their existence, and we'll try to develop the necessary technology in your absence. But even if we could create wormholes and travel through them, would it be worth it? Is it worth tilting the Earth and rearranging the solar system just to visit another galaxy? Or go back in time? Read your history, read your science fiction, see all the movies, and play all the games you want. But let's be glad our solar system is the way it is. Would we even be here if it wasn't?
What would happen if you took the most energetic light source in the universe and smashed it into a massive gravitational monster? Well, you might reverse the flow of time. How would this event unfold? How could it affect time as we know it? And what would happen if you got too close? This is What If, and here's what would happen if a gamma ray burst hit a black hole. Meet your first fighter, a black hole. Not so different than your average object with mass, except that it's extremely dense. Most black holes are the remnants of massive stars, and
They have lots of gravity. The mass of this black hole is compressed to a point called a singularity. At this infinitely small point in the center, conceptions of space and time break down. Today's challenger is a gamma ray burst. Not so different from your average burst of visible light. Oh yeah, except way more energetic. Gamma ray bursts are the strongest and brightest explosions in the universe. In 1 second, gamma ray bursts emit as much energy as the sun will emit during its entire 10 billion year lifespan. So, if these two powerful phenomena collide, would space and time cease to exist? There are a couple of things you should know before we get underway with our space-time obliterating cage match. The first is that our two contenders already interact pretty often. A black hole releases a burst of gamma-ray light when it's created. This burst spreads out evenly in all directions across the universe. So some of these gamma rays will certainly encounter another black hole or two. And these gamma ray bursts happen about once a day. They could flash for less than 2 seconds, or they could last for up to 30 seconds. The difference is whether the burst results from two neutron stars colliding to form a black hole, or whether it's the result of a star collapsing directly into a black hole without a supernova explosion. So, if you managed to observe these phenomena, would you witness a magnificent explosion about 1,000,000 trillion times brighter than the sun? Well, not quite. While some photons have just the right amount of frequency to be visible to your eyes, the frequency of gamma rays is way too high. Your eyes aren't advanced enough to see their beautiful bursts. But if you could see them, this insane amount of light would probably leave you blind. Now, surely this explosion must be loud, right? Well, once again, I come bearing bad news. It would technically sound like nothing. Yeah, sound doesn't travel in the vacuum of space. It needs a medium with particles to carry sound waves. But thanks to the scientists at NASA, a gamma ray burst would sound a little something like this. Okay, not exactly like this. These beautiful cello and piano notes translate the gamma ray frequencies into musical notes. Pretty mellow for such a massive explosion, right? But if you were close to this explosion, things would be anything but mellow for you. Gamma rays are hazardous. They can penetrate lead, concrete, and certainly whatever spacesuit you'd be wearing. As they passed through your body, they deliver an extremely high dosage of radiation. You'd suffer radiation sickness. You'd become nauseous, lose your hair, and even bleed. The energy could cause damage to your tissue and your DNA, leading to cancer or, worse, death. The gamma rays could cook you from the inside out. So you'd want to back up a little bit. Or better yet, reverse time. In 2018, researchers observing gamma ray burst pulses found that some events repeated themselves in reverse. That's right, it was as if they were moving backward. So, what does this mean for you? Did you just stumble on a way to travel back in time? Again, I have bad news. This is merely an optical phenomenon. Light has the fastest speed in the universe, but this is only true for the speed of light traveling through empty space. In other mediums, like water, it would be possible for electrons to travel faster. That means if gamma rays could travel faster than the speed of light, they would give the illusion of reversing time. So yeah, it's possible I oversold you a bit on the idea that if a gamma ray burst collided with a black hole, it would result in the brightest, loudest, time-destroying explosion of all time. But in some ways, it's all true. Stars are gigantic balls of fire holding planets, asteroids, and meteorites in their firm gravitational grip. And their fire sends light into the farthest reaches of their galaxies. But how did they get here? I mean, these incredible orbs must have come from somewhere, right? What would it be like to witness this epic birth? What would it feel like at the center of the action? And why would this beautiful event have a funny smell? This is What If, and here's what would happen if you saw a star being born. The Milky Way galaxy spans about 100,000 light years across, and it contains somewhere around 200 billion stars. If there are that many stars in our little section of space real estate, imagine how many there are in the entire universe. Now, depending on where you look in the night sky, you could see around 5,000 stars just with your naked eye. The brightest ones have melodic names like Polaris, Alpha Centauri, and Betelgeuse. Looking further out into the universe with the help of telescopes, there are simply too many stars to name.
That's the North Star. Well, what is that?
That's why many of these are now identified more generically, like WASP 50, HD 28678, and HAT P23. But today, you're not just going to look into a telescope and name some baby stars. You're going to be in the thick of it. The hot, dense thick of it. Every year, 7 new stars are born in the Milky Way alone. Now, that might not sound like a whole lot, but keep in mind that our galaxy has already used up 90% of its star-making material over the billions of years of its existence. And yet, new stars are still being born all the time. Now, to witness their birth, you need to travel to one of the many star nurseries in the universe. These are known as nebulas. Nebulas are huge clouds of gas and dust that can span light years across. So, hop into your interstellar spacecraft and set your coordinates for one of the most famous stellar nurseries of our galaxy, a mere 1,344 light years away. The Orion Nebula. Yeah, it's here that you'd find the necessary ingredients for a star to be born. Gas, dust, gravity, and turbulence. Sounds like my car. Being in the middle of a nebula would feel like being in the clouds. You'd be surrounded by over 200 different kinds of molecules. There would be hydrogen and helium gas, as well as microscopic grains of silicon and iron. And I hope you packed some warm clothes because conditions in this cloud would be frigid. You'd need a spacesuit thick enough to withstand temperatures as low as minus 270 degrees Celsius. But don't worry, things are about to heat up. Suddenly, you'd be hit by a blast. This would be a ripple effect from an exploding nearby star, and it would cause the nebula to become turbulent. All it means is that the gases around you would start to mix and swirl together. It would be the beginning of the epic event you're here for. First, dust particles would begin to clump together. These clumps would become denser and denser, forming knots. Once these knots gain enough mass, they'd start to collapse under their own gravity.
and their internal pressure and temperature would increase. Yeah, at around 2200 degrees Celsius, these high-pressure knots would emit a dull red glow. You wouldn't be able to see it because that light would be infrared, but you would be uncomfortably aware of the temperatures starting to rise. And things would keep heating up. Eventually, the protostar before your eyes would emit its first rays of visible light. Wait, do you smell that? Well, no, of course you don't. You're wearing a heat-resistant spacesuit, but if you could, you'd learn that this hot mass of dust and gas would also smell.
It's disgusting.
But not necessarily in a bad way. Depending on the mixture of compounds around you, you could detect hints of sweetness, lemon, or even alcohol. But be careful, your baby star wouldn't only be pulling things inward. Every now and then, it would shoot powerful jets from its poles at supersonic speeds. These would flash brightly as they come into contact with the surrounding gases. All the while, the protostar would simultaneously grow and collapse under its own weight. This would make the core continue to heat up. Yeah, once it reached the scorching hot temperature of 5 million degrees Celsius, you'd witness your baby star's first nuclear fusion. Deep within the center of the star, 4 hydrogen atoms would fuse together to form helium. This would release a ton of energy. And with all that energy, the protostar's pulsations would come to a halt. It would finally become a star. Now, during the excitement of witnessing a star being born, you'd have seriously lost track of the time. If the star that formed in front of your eyes was similar to our sun, well, you'd have just watched 50 million years fly right by you. And you might want to get your hearing checked after experiencing all this. Of course, there's no sound in the vacuum of space, we all know that, but in the stellar nursery filled with gas and dust, sound waves may have a medium to travel through. And if you were wondering what the birth of a star sounds like, well, it would be deafening. If we could hear our own sun, it would be a lot like Earth was covered in constantly wailing sirens, except multiplied by 10,000. A new star created by a series of violent contractions of superheated gas? Ugh, forget about it. Okay, now that your baby star is all stabilized, it could burn bright for another 10 billion years. We've thrown a lot of disasters at Earth over the years, from asteroids and aliens to the sun's death. But hey, the universe is a dangerous place, and we're not done yet. Now we're going to throw a black hole into the mix, and not just any black hole, but a blazar. How old is the oldest blazar? Why can we see some blazars but not others? And what is the Doppler effect, and how would it let us know that a blazar is on its way? This is What If, and here's what would happen if a blazar entered our solar system. Black holes are found at the center of most galaxies. The Milky Way has a black hole that is 4 million times the mass of the Sun. But that's small compared to other black holes out there. For instance, there's PSO J0309 plus 27. This galaxy is the oldest ever discovered at around 13 billion years old. And since the universe is only 13.8 billion years old, PSO J0309 plus 27 has basically been around almost since the beginning. At the center of this galaxy is a supermassive black hole that
could fit 250 black holes from the Milky Way. Because of this crazy big black hole, PSO J0309+27 is considered to be a blazar. And blazars are the most extreme type of active galactic nuclei, or AGN for short. But what are active galactic nuclei? Well, there are different types, a blazar being just one of them. But basically, they're galaxies with supermassive black holes that spew tons of energy, which could range from radio waves to gamma rays. Because they give off so much energy, they are the brightest objects in the universe. So, what makes a blazar special? Blazars are extremely rare. There are anywhere from 200 billion to 2 trillion galaxies in the universe, and only 1 out of every 10,000 galaxies are blazars. But what makes them really spectacular are the jets of material shooting out from the top and bottom of their rotating disks. These jets are supercharged with magnetic fields and radiation. The material inside them can travel just under the speed of light, and their lethal radiation beams are pointed straight at Earth. Let me be clear, it's not just some blazars that are pointed toward us, but all of them. Any blazars that aren't pointing their deadly jets in our direction are invisible to us. So, what blazar would be the most likely to enter our solar system? Well, let's go with the closest one to Earth, Markarian 421 at 400 million light-years away. How would we know it's coming, and when would it start affecting Earth? Well, scientists would know that Markarian 421 is getting closer to Earth almost right away. The light from the blazar would change from red to blue. Changes to the light's wavelength would cause this, and it has to do with the Doppler effect. This is a hard one to explain, so I'm going to use a metaphor. You've just pulled over to clear a path for an ambulance, and as the ambulance approaches you, its siren has a higher frequency, but once it passes and speeds away from you, its siren has a lower frequency. Both sound and light behave like waves, so you can use the same idea for the Doppler effect. When a galaxy moves away from you, the frequency of its wavelengths become lower and shift toward red. When a galaxy moves toward you, its wavelengths have a higher frequency and shift toward blue. Most galaxies in the universe are red-shifted because the universe is expanding. So, if Markarian 421 suddenly changed to blue, astronomers would know right away that it was heading toward us. How long would we have? Well, even at the speed of light, it would take Markarian 421 400 million years to reach Earth. But it doesn't have to reach Earth to cause damage. Its jet could be hundreds of thousands of light-years long. Our galaxy is only 100 light-years across, so Markarian 421 would begin blasting our solar system with radiation before it even entered the Milky Way. Blazars are also known to blast off from time to time. This giant flare can last from minutes to months. If Markarian 421 blasted off within a range of our galaxy, its jet would punch a hole straight through our solar system. It would be a doomsday scenario, and there wouldn't be anything we could do to save ourselves.
This is the Sun. And this is a neutron star. But don't let its size fool you. Neutron stars are massive gravitational monsters, and orbiting one wouldn't end up well for our planet. But what if we took just a spoonful of it and transported it to Earth? Such a tiny amount of a neutron star couldn't possibly destroy us all. Or could it? This is What If, and here's what would happen if a spoonful of neutron star appeared on Earth.
When a star about 4 times the size of our Sun explodes in a supernova, it propels its outer layers into space, leaving only a dense, collapsing core behind. A neutron star. Neutron stars are very, very dense. They could have the diameter of a small city, but their mass would be 1.4 times the mass of our Sun. Of course, no neutron star will ever appear on our planet by itself. First, you'll have to grab a spoonful of it and bring it back to Earth. You'll find the nearest neutron star, nicknamed Calvera, 617 light-years away from Earth. If you jumped in the fastest spaceship we've ever built, it would still take you 11 million years to travel to Calvera. I'll have to fast forward here and meet you in the neutron star's neighborhood. You'd be trying to get your spacecraft through a magnetic field that's tens of millions of times stronger than Earth's. Your ship's computers would be useless if they had any ferromagnetic materials like iron, nickel, or cobalt in them. You wouldn't want any of those materials anywhere in your craft. You'd have to dodge the electromagnetic radiation beams shooting from the star faster than you can blink. And then, when you finally manage to get to the surface of Calvera, you'd be immediately vaporized due to the temperatures being around 1 million degrees. Celsius, Fahrenheit, at this point, would it even matter? Any part of your craft that wasn't vaporized would be crushed by the star's intense gravity. But let's not end your story right there. Instead, let's equip you with a supersuit that could withstand the insanely hot temperatures and the extremely high pressure of a neutron star. And here you have it, a spoonful of Calvera loaded on your ship. Now what? If you tried to scoop the Sun with a teaspoon, you'd only get about 2 kilograms of it. The same amount of a neutron star would weigh anywhere from 1 billion to 6 billion tons. You wouldn't be able to lift that spoon in the first place. And that's not even the worst part. Because the gravity of a neutron star is so intense, it fuses protons and electrons together. Only neutrons are left in that stellar core. When they aren't buried down inside a star, neutrons don't last too long. After 10 minutes, the scoop of a neutron star would break down into protons and neutrons and release as much energy as the Sun produces in 2 or 3 seconds. Good thing you didn't have enough time to bring that stuff back to Earth. Leave neutron stars where they belong. Far, far away from us. And if one ever comes a little too close to Earth, jump on a spaceship and escape to another planet outside the solar system. But that would be a story for another What If.
Black holes are one of the most devastating objects in space, sucking up everything around them. But there's another space phenomenon that's just as destructive. And it's known as a white hole. Now, what would happen if these two objects met in space and fought each other? Could something like this even happen? Who would win? And what is a white hole anyway? This is What If, and here's what would happen if a white hole fought a black hole. Before we get to our fight, let's see what these two opponents are all about. In one corner of space, we have the black hole. This legendary space occurrence is probably pretty familiar to you. Its signature move is to consume every piece of matter it comes in contact with. The white hole, you're probably less familiar with. And its signature move is to expel energy rather than sucking it in. So, with our two fighters having completely opposite attack strategies, who would win? Despite us not knowing much about our white hole mystery opponent, it's much more experienced at conquering space than the black hole is.
That's right, the white hole is a proper journeyman and has been roaming space for millions of years, kicking butt and taking names. That's because scientists theorize that this white hole used to be a black hole. Scientists suspect that after millions of years, black holes will become white holes. And all the energy and matter they consumed over the years will be expelled back into space. That being said, when a black hole becomes a white hole, it might not last very long, so it will need to act quickly if it wants to pick a fight with a black hole. And despite it being different, the white hole is just as destructive as a black hole, if not more so. The matter the white hole is ejecting moves at the speed of light. So it's safe to say that the white hole is the veteran fighter in this situation as opposed to this up-and-coming black hole, but how much will its experience help it? After millions of years of causing destruction throughout the universe, our two opponents finally meet. They've battled asteroids, planets, and even stars, but they always managed to survive. Now they both face their greatest opponent yet. As these two massive forces approach each other, the black hole will instantly gain the advantage. The white hole will do its best to prevent the black hole from overtaking it, but unfortunately, it really doesn't stand a chance. That's because the white hole has no choice but to spit energy at its opponent. Although it was able to defend itself against everything else in the universe, unfortunately, the black hole is its one true match. The mass the white hole is expelling is also being turned into energy for the black hole. This won't be a quick battle either, as the black hole can feed on the white hole for thousands of years. And as it keeps feeding, the black hole is getting larger and larger. And now the black hole is ready for the finishing blow. It completely swallows the white hole. Now that it's consumed so much energy, our black hole is more massive than ever. It might be as big as the Messier 87, which is 38 billion kilometers across. For reference, that's 3 million times larger than Earth. So, if a white hole and a black hole collided, we'd have a massive black hole roaming around the universe, destroying everything in its path. And if it were anywhere near us, well, that would mean humanity would be in some pretty big trouble.
See that bright object in the sky? That's Andromeda, the closest major galaxy to our Milky Way and the most distant thing you can see with the naked eye. And it's racing towards us at the rate of 110 kilometers per second. Eventually, 4 billion years from now, Andromeda will merge with our Milky Way in a huge galactic collision. But what if these galaxies were to collide tomorrow? Would all the stars and planets suddenly plow into each other? Could our solar system survive this massive crash? And what would this galactic light show look like from Earth? This is What If, and here's what would happen if the Milky Way and the Andromeda galaxy collided. There are at least 100 billion galaxies in the observable universe, all colliding with each other. Larger galaxies merge about every 9 billion years, while smaller ones slam